Okay, question 2. So it says a spinner with 3 equal sections was spun 100 times. The spinner is shown at right, and the table of results are shown below. So a 1 happened 40 times, a 2 happened 35 times, and a 3 happened 25 times. So our first question, and this is all going to be very similar to number 1, it's just a second attempt. So our first question says find the experimental probability of spinning a 3 and roll it as and write it as a fraction, decimal, and percentage. So we're going to start there. So remember, we did the experiment, meaning we spun the spinner 100 times. So our denominator will be the total outcomes. And our numerator will be the number of times the outcome we're looking for happened. So 25 times we got a 3. So it was 25 out of 100, which we can reduce to 1/4. So 1 out of 4 times, we got a 3. So now we need to, so that's it as a fraction. To do it as a decimal, to turn a fraction into a decimal, we divide our numerator by our denominator. Okay, we can do it with either 25 and 100 or 1 and 4. We'll get the same answer, which equals 0.25. So there we have it as a decimal. And then to turn a decimal into a percentage, we move the decimal place 2 to the right, it's 25%. And now we have to compare that to the theoretical probability. So for the theoretical probability, we're going to look at the number of possible outcomes, which is 3, 1, 2, and 3. That's going to be our denominator. And our numerator will be the outcome we're looking for, how many times it happens. So we get a 3, 1 out of 3 times. So we have 1 out of 3 times for the theoretical probability, 1 out of 4 for the experimental probability. So when it says compare them, just means the theoretical probability was bigger, and that's it. And compare them, 1/3 is greater than 1/4. It would happen more in theory than it did when we actually did it. So now it says, are the theoretical and experimental probabilities different? Would you expect them to be? So this is sort of just, the first part is just a reframing of the compare. Probably could have, we'll just do that. Probably could have gotten rid of that. So are they different? Yes, they are different. Would you expect them to be? And this would be, you could even have basically the same answer as the last one, even though they were the same in the last problem. I would say I would not expect them to be. Usually the experimental probability and theoretical probability are not identical. If I flip a coin 20 times, I'm not going to get 10 heads, 10 tails every time, but they're often close. So I would expect them to be different, but close. Now, C asks us, what would we expect to happen to the experimental probability of spinning a 3 if we were to spin the spinner 1,000 more times? And explain. So this one is, we did the assignment where we did our coin flips and we recorded what happened, and we discussed what happens to an experimental probability the more times you do the experiment, spinning the spinner, flipping the coin, etc. So we expect over time that the more times you do an experiment, the closer the experimental probability will get to the theoretical probability. It's just how it works. If I flip a coin 4 times, I could get 4 heads. But if I flip a coin 1,000,000 times, I'm absolutely not going to get 1,000,000 heads. So the more times you flip a coin or spin a spinner or roll a dice, the closer the experimental probability gets to the theoretical probability. And now D asks us, are spinning a 1 and 3 complementary events? Why or why not? So remember, with complementary events, we're going to look at the experiment or the theoretical probability. So our theoretical probability of getting a 3, I'll just do it as a fraction. I think that's the easiest for complementary events. So there's 3 possible outcomes on our spinner. 1, 2, and 3. And one of them is spinning a 3. So I have a 1 in 3 chance of getting that. And then there are 3 possible outcomes. So I make 3 again my denominator, and one of them is a 1. So the probability of getting a 1 is 1/3. So I add them together and see if they equal 1 or 100%. If I'm using a percent, they don't. They equal 2/3, which is less than 1. So they're not complementary events because their combined probabilities are less than 1 or less than 100%.